So this is the 2016 Leaving Cert Higher Level Paper 2 and we're looking at question 7. A glass roof lantern in the shape of a pyramid has a rectangular base CDEF and its apex is at B as shown. The vertical height of the pyramid is AB, length AB, where A is the point of intersection of the diagonals of the base as shown. So this is where the diagonals cross each other. Also, the length CD is 2.5 meters and the length CF is 3 meters. Part A says, part A1, show that the length AC is equal to 1.95 meters correct to 2 decimal places. So we're looking for the length AC. So we're looking for this length here, AC. Now, what we can draw is the triangle CDE. If we imagine that triangle there, CDE like so. I'm redrawing that triangle. Well, I know that's a right angle down there because it's a rectangular base. I know this side's 2.5 and I also know that the side ED should be the same as the side FC, which is 3. So I know two sides and I can use Pythagoras to find the third side. And when I found that, I know that CA will be half of that because the diagonals of a rectangle bisect each other. So I can use Pythagoras. Pythagoras is in the tables book here. I've taken this from the tables book, so you can just match it up. We're looking for, I'm going to call CEX for the moment. So you can see here that the C would be our X, the A, which you go there, will be our 3, and then this here would be our B, which we're going to plug in there. So using that color coding, we're going to plug in those values to Pythagoras theorem. So that's going to give us the yellow squared, which is x squared, is equal to the green squared, which is 3, plus the blue squared. Okay, so that gives us x squared is equal to 15.25. So x will be the square root of 15.25 and that gives us 3.905 and on it goes like that. So that's going to be CE, but we want half of that to get AC. So the length AC will be equal to x divided by 2. So if we divide this by 2, that gives us 1.9525 and on it goes. And if we round this correct to 2 decimal places, we look to the third digit after the decimal. This 2 does not affect the 5 in front, so that gives us 1.95, and that's what we were asked to show, 1.95 meters. Part 2 says the angle of elevation of B from C is 50 degrees, i.e. the size of the angle BCA is 50. Show that AB is 2.3 meters correct to 1 decimal place. Okay, so the angle BCA is 50. So the angle BCA, that would be this angle here. If you can imagine the triangle BCA, we're going to draw that triangle now, the triangle BCA. So if I draw the triangle BCA, this is our angle here that's 50 degrees. I'm looking at the triangle flat now. So it's B, C, and then A. So B, C, and A. So we have to show that AB, this here, is 2.3. This would be a right angle triangle. Okay, now we've just worked out AC. We know AC is 1.95. So we're going to try and find AB. So if I call AB Y this time, you can see here that I have an angle and a side, and it's a right angle triangle, and I'm looking for the other side, or another side. So I can use sin, cos, or tan. So I can see here that from this angle I'm looking for the opposite, and I have the adjacent, so that's going to be tan. You can get this from your tables book as well. So the tan of the angle is equal to the opposite over the adjacent, 1.95. So y, the side we're looking for, will be 1.95 multiplied by the tan of 50. And that gives us y equal to 2.2 well, let's check that. That gives us 2 point, a mistake there, 2.323, and on it goes. So correct to one decimal place. We look to the second digit. This doesn't affect the 3 in front, so we get y is equal to 2.3 meters, which is what we were asked to show. Okay, so part 3 then says find the length BC, correct to the nearest meter. So we now need to find BC here. Well, if I look at this triangle again, I have this side's 1.95. This side I've just worked out is 2.3. So again, this is C, A, B, and I'm looking for BC. Find BC. So I'm going to call this BC here W, and I'm going to use Pythagoras again. So W squared is equal to 2.3 squared plus 1.95 squared. So that gives me W equal to the square root of all that. So when I work all that out there in my calculator, that gives me a value of 3.0153, and on it goes. But I want this correct to the nearest meter. So that's going to be 3 meters. So that's BC. Okay, moving on. Part 4 says find the size of the angle BCD correct to the nearest degree. Okay, the size of the angle BCD. So I'm going to go back to my original diagram. So BCD. So I need the size of the angle BCD will be this angle here on the triangle BCD. So if you can imagine the triangle BCD. So BCD will be like this. So you've got B at the top and then CD. So B here, C, and D. Okay, so we know that if we go back here, we know CD is 2.5 and BC we just worked out was 3. So BC is 3, CD is 2.5, and because that will be an isosceles triangle, this side here will also be 3. And I'm looking for the angle BCD. So I'm looking for this angle down here. I can call this angle here X. So if I've got this triangle is not right angled, I have three sides and I'm looking for the angle. So I'm going to use the cosine rule, which is down here, taking it from the tables book. So all I need to do then is to match up the correct parts. So if I'm looking at the angle, if X is my angle A, that's what I'm looking for. So then my sides, this would be B. This one here would be B. So that's going to go in there and there. This here will be my C value, which will go here and there as well. And my A, which is what I'm looking for, or sorry, my A value rather would be this. So that's going to go in there, the A value. So I'm going to be looking for the X, or in other words, the A, the angle. That's what I'm looking for. So I'm going to set this up. So I get the blue squared, so 3 squared is equal to 2.5 squared, the yellow, plus the green squared, minus 2 times B, which is 2.5, bracket C, which is 3, by the cos of X, which is what I'm looking for. Okay, so I'm now going to do some work on this. So over here, I'm going to bring both of these here over to the other side, and they're going to become minus 2.5 squared and minus 3 squared. So what that gives me then is minus 3 squared, 3 squared, nothing, so I'm going to have and that would be minus the 2.5 squared. So that's going to be negative minus 6.25 over here. That's equal to minus 2 by 2.5 by 3. So minus 2 times 2.5 times 3. That gives me minus 15 by the cos of X. So dividing both sides by minus 15, the cos of X is minus 6.25 divided by minus 15. So X will be the inverse cos, so shift cos button of minus over minus is plus, so it's shift cos of 6.25 over 15. And that gives me an answer of 65.375 on it goes, but I want it correct to the nearest degree. So to the nearest degree, I'm going to look at this 3. This doesn't affect the 5 in front. So the answer then is size of the angle BCD is 65 degrees to the nearest degree. Part 5. Find the area of glass required to glaze all 4 triangular sides of the pyramid. Give your answer correct to the nearest meter squared. Okay, so I need the area of the 4 triangular sides of the pyramid. So I need the area of this here, and this is going to be, there's going to be 2 of these faces. That's going to be the BCD, and then at the back BFE. So two of them will come from that. For the side FBC and EBD, those side pieces, that's 3 FC, and remember this here, BC was 3 as well. So those triangles are equilateral on the sides. They're equilateral triangles of 3 meter side. So for that one there, BCD, I have, that's 3, that's 3. Remember this was 65, so that means this here is 65 degrees. 65 and 65 gives me 130, so that leaves 50 up there. That's 50 degrees. So if I want to find the area of this triangle here, I can use this formula down here, half AB by the sine of C. So half the multiplication of two sides by the sine of the angle between them. So the area of this face is going to be half 3 by 3 by the sine of 50 degrees. And remember, there's going to be two of these, front and back. And then the other triangle, remember, is an equilateral triangle. It's 3, 3, and 3. And equilateral triangles have angles of 60 degrees. So for this one, there's going to be two of these as well. This is going to be a half of 3 by 3 by the sine of 60. And then I'm going to add both of these two together. So on top then I'm going to get 2 by half is 1, 3 by 3 is 9, so 9 sine 50 9 sine 50 plus, down here I'm going to have 9 sine 60. So that gives me an answer of, when I add both of them together, so this and this get added, and the answer coming out is 14.68, oh sorry, 14 I meant. And on it goes, but we want the answer correct to the nearest meter squared. So to the nearest meter squared, it's going to be 15. So the area is 15 meters squared for the whole 4 triangular sides. Okay, and finally, part B. Another roof lantern in the shape of a pyramid has a square base CDEF. The vertical height AB is 3 meters. So AB, this side here, that's 3 going from A to B, where A is the point of intersection of the diagonals of the base as shown. The angle of elevation of B from C is 60. So that's this angle in here. That's 60 degrees when you're looking in there. Find the length of the side of the square base of the lantern. Give your answer in the form root A meters. Okay, where A is an element of the set of natural numbers. So we've got a square base, so that's what we're going to be looking for. I'm going to call the, well, let's call each side x. So square base of side x, and that's what we're looking for. Okay, so what I need to do then is I need to find something on the ground. So I need to find the length AC. So if I look at the triangle BCA from the side like this, if I look in from the side, I've got BCA, it's right angled. I know this is 60, and I know that this side here is 3. So if I can find AC, I'm just going to call this Y. If I can find that, AC. I can double it to have CE, and then I can look at this triangle ECD, and that's X, and remember this side here will be X as well. Okay, so how do I find this side here? Well, here I'm going to use a trigonometric ratio. So it's either sin, cos, or tan. I've got this angle, I've got the opposite, and I'm looking for the adjacent, so it's tan. So I can say that the tan of 60 degrees is 3 over y. So then y would be 3 over tan 60, and I rearrange that. So that gives me y is root 3. Okay, so if y is root 3, that's AC, I want CE will be double that. So the length of CE is 2y, which is 2 root 3. Okay, so now CE is 2 root 3. So if I draw the triangle CED now, CED, this will be 2 root 3. This is X. This is X, and that's the right angle. So I can do Pythagoras here, and I can say that the x squared plus the x squared is equal to the hypotenuse squared, so 2 root 3 whole squared. So on the left I get 2x squared is equal to 2 squared is 4, root 3 squared is 3, 4 threes is 12. So divide both sides by 2, x squared is 6. So x will be root 6. And that's my answer in the form root a, where a is a natural number because 6 is a natural number. So my answer then is root 6 meters. And that's the end of part B and the end of question 7.